So rather than go through all the different functional group questions that one can pluck from A-level papers, I thought it would make more sense to go through reaction types. Now there's going to be a few A-level questions that will slip through the cracks in this approach, but first of all it means that now you've got practice questions on functional groups with the main worksheets, but now gathering together A-level questions of the same type really emphasizes what the examining board are looking for and what kind of questions one can almost predict might be on the exam. So starting off with some easy ones, ester can be hydrolyzed by heating with aqueous sodium hydroxide. Give the equation for the hydrolysis of methyl ethanoate, where here's the methyl ethanoate formed by ethanoic acid and methanol. Put that in basic solution. Now do remember it's in a basic solution, and so we will split it up again, not into the acid and the alcohol, there's the alcohol, but instead of the acid we have the sodium salt of the conjugate base of the acid, so ethanoate rather than ethanoic acid, because we are in basic solution. And that's something to absolutely make sure you have rammed into your head, that when you have an acid in basic solution you don't have the acid at all, you have its conjugate base. 1-bromobutane liquid insoluble in water converted to butanol in one-step reaction. Very, very common type question here. Give the reagents and conditions for this reaction. So what we want is we want to turn the bromide into a hydroxide. Now at the A level, they use hydroxide for substitution reactions and elimination reactions, and they make a very strong distinction between the conditions to use to give you either substitution or elimination. In this case we use aqueous sodium hydroxide and heat below 110 degrees Celsius, obviously because you've got water in there, and it's the aqueous sodium hydroxide that leads to the substitution reaction. If you use ethanolic sodium hydroxide you get an elimination reaction. So keys, if you like, for how to answer the A-level questions appropriately. Just to emphasize how much they like it, something plucked from another question. 1,4-dimethylbenzene reacts with chlorine to give this blah blah blah, absolutely irrelevant. What is important is give the displayed formula of this compound produced when 1,4-dichloromethylbenzene reacts with an excess of aqueous sodium hydroxide. There's the aqueous sodium hydroxide again. Here you have aliphatic chlorides. Ignore the fact you've got the benzene ring here. These are aliphatic chlorides, so they're just going to substitute to give you the di-alcohol. Okay, excess of it means that you're going to get both of the chlorides substituted by hydroxides. So last two questions have converted a Cl or a Br to an OH. Now we're converting an OH to a Cl. You have to be careful with some of these halogenating agents, but some nice ones to bear in mind. Anytime you've got an OH, whether it be an acid or a primary alcohol, is that you can use SOCl2, sulfonyl chloride, or the two phosphorus chlorides, phosphorus 3 chloride or phosphorus 5 chloride to do this conversion. Reaction sequence to produce 4-bromophenylethanoic acid is shown below. That's that one. Two little parts of it. First of all, what's the name of reagent F? Reagent F turns a bromide into a cyanide. So you use NaCN or KCN to accomplish that nice substitution. And then reagent G, what we're doing here is we're turning that cyanide or nitrile group into the carboxylic acid. And this is a hydrolysis reaction, so you just react it up with water with an acid catalyst. Now we've got a fairly big reaction scheme, but there's no mechanistic questions associated with it, so I've got it in this first part of the question seeds. Seeds of sweet pea contain 3-amino-propane nitrile. One way to prepare it, and some of the reactions are outlined below. So we can start off with the amine chloride with reagent J that we'll discuss in a minute. You turn the chloride into the cyanide, so now you've got 3-amino-propane nitrile. And then you can do all kinds of fun reactions with these, each of which we will discuss individually. So reagent J, so this is for this first one, in which we turn a chloride into a cyanide, and as we have discussed, that's with NaCN or KCN, nice straightforward substitution reaction. Now we're looking at reagent K, okay, that turns this cyanide, amine, into this complex. So we leave the cyanide alone, but we now go from an amine to an amide. And of course, the way you go from an amine to an amide is you just react up with the appropriate acid chlorides. So in this case, CH3C double bond O is the acid part of it. So we have the chloride reacting up, losing HCl. Now we're looking at M. So M is where we take now the amine nitrile. We don't touch the amine end, but we turn the nitrile or the cyanide into the carboxylic acid. We've already seen this. This is just a hydrolysis reaction with acidified water or with aqueous acidic solution, however you want to think about it. And finally, as if you were going to guess, we'll talk about what N is. So with N, again, we leave the amine alone, but we're reacting up the nitrile. We are, of course, reducing or hydrogenating the nitrile to get to the amine. And so this can be done with lithium aluminium hydride, anhydrous, or of course hydrogen with a metal catalyst.